So good morning everybody, myself Acharya Vishwendra. Today I am discuss some of the questions based on the magnetic flux and the calculated parameters based on that. So here is a question where magnetic field is given to you and we need to find at what point rate of change of magnetic field is maximum. So you can see that here the rate of change is equal to tan theta. So here the angle is maximum 60 degree. So rate of change is going to be maximum in this particular part which is given by the region OA. So this is answer to this particular question. In the next question we need to analyze the magnetic potential energy stored in an inductor. So we know that the expression for the magnetic potential energy in an inductor is half Li square, where L is the self-inductance of the circuit and I is the current flowing in the circuit. Now the question is that if we make the current half, that is I converts to I by 2. So obviously there is a square term, so potential energy will be I by 2 whole square, that is 1 by 4. So potential energy will become 1 by 4th. So hence we can say that potential energy will reduce to 1 by 4th. Next is we have a question on the same basis that potential energy will be 1 by 4th. So 1 is correct over here. In the next question there is a problem on the power generated in a circuit. So power, we know that it is I square R. Power is given to be 400, current is given to be 2. So by calculations we get resistance as 400 ohm. Now we need to find the total potential drop across the the circuit. So we know that if small r and capital R are in series, the effective resistance is R plus R. So using the Ohm's law, V is equal to I, R plus small r, I is here 2, R comes out to be 110, so it is 220 volt. So in this way you can calculate this. So power consumed in the external resistor is 400 ohm and internal resistance is 10 ohm. These are the calculations based on that. Next one, now we have a question based on the induced EMF. So induced EMF is NB omega sin omega t. So this term I write as E naught. So E is equals to E naught sin omega t. If time is pi by 2 omega, we substitute the expression for time. Then we have E is equal to E naught, which is plus V. Next one, now we have a question based on the flux. So if flux changes, induced EMF will be there and heat will be there. So temperature will increase. So hence option 3 is correct over here. Next is we have a question on the calculations of induced EMF. So induced EMF is change in flux per unit time. Flux is Bs cos theta. So using the calculations over here, the induced EMF comes out to be 1 millivolt, and since current is E by R, so we have 1 upon 0.5, which gives the result as 2 milliampere. Next question is based on calculations of self-inductance. So using the formula E is equals to L delta I by delta T, we have L is equals to 4 Henry. Next is a problem based on calculation of mutual inductance. So we know that phi is equals to M into I. So delta phi is M into delta I. Change in current changes from 20 to 0. So from here we get delta phi is 30 Weber. So fourth is correct. So these were several questions based on electromagnetic induction. If you have any doubt, you can ask in the comment section. Thank you and have a nice day.